The universe is an absolutely beautiful place, a lot of its lovely colour coming from galaxies and their stars. And while today we are finally free of the gloomy grey clouds covering my sky for days on end, I want to instead focus on the absolutely amazing clouds that bring immense colour to the universe. Nebulae. I'm Seti, I'm a PhD student studying the Milky Way, and I also love to make spacey content for you guys. If that's something you're interested in, I highly recommend you subscribe and click on the notification bell. Today we're going to be talking about nebulae, more specifically what they are, the different subtypes, and how they all differ from each other. I'll also be giving you my favourite examples of each of the nebula types. Most nebula are what we would call diffuse nebula, and these are made up of little pockets of dust and gas that are spread out around the universe. They're diffuse because they don't really have a clearly defined boundary. Instead, the edges kind of just fade out into just the general void that is the universe. What's really important about these kinds of nebulae is that they will usually have a nearby star, either nearby it or embedded within it. And it's the interaction between the nebula and this star which is what gives us these three important subtypes within diffuse nebulae. That is emission, reflection, and absorption nebulae. Another interesting thing about the star is that its stellar winds, if they're quite strong, can also give really unique features within the nebula, which make them all a little bit more, I guess, unique. The key thing is that the nebula type depends on how the nebula interacts with the nearby star on the particle level. More importantly, how the light from the star is processed within the nebula. Let's start off with our first subtype, and that is emission nebulae. These are caused when that nearby star is hot enough to actually ionize all or most of the gas within the nebulae, which is mostly comprised of hydrogen, but you do also get other very interesting elements which create a little bit more of a colour gradient or very interesting colours within the nebulae. Most of these stars that create emission nebulae are what we would call O or B type stars. So these are the hottest stars that we can observe, with surface temperatures roughly around 20 to 30 plus thousand Kelvin, so very, very hot, but usually it will be on the hotter end of this, so above 25,000 Kelvin as sort of a general rule of thumb. It is the radiation from this ionized gas which is what we see in the emission nebula. I personally think the Carina Nebula is a really fun example. It's a really huge, I guess what we could call like a nebulous complex. Within it are many other individual smaller nebula, including the Homunculus Nebula, which is an emission type nebula. I am saying the word nebula so much right now. This is caused by the ionization of gas from the stellar system Eta Carinae, which we think are at least two stars, one of which probably being an O-type star. Next up are reflection nebulae. So if the nearby star isn't actually hot enough to ionize most of the gas, instead that light can be used to actually be scattered within the nebula, within the dust and the gas that make up the nebulous cloud. This is why they tend to look a little bit more blue in general, because blue light scatters a lot better than red light, a bit similar to why the sky is blue during the daytime. Reflection nebulae tend to be a little bit more dimmer on average compared to emission nebulae, and this is mainly because the host star, because it's not as hot as, say, an O or B type star, it's going to be much cooler, and as a consequence it will also be a tad bit dimmer. My favourite reflection nebula is probably going to be the Witch's Head Nebula. It's very ghostly in this image. The blue and violet colours look quite ethereal and mystic in my opinion. This nebula is lit up by Rigel, which is a very cool B-type star that's a little bit too cool and too distant from the nebula to really ionize it like the way an emission nebula can be. A much more updated image that really clearly shows the nebula and Rigel is this one. I absolutely love this image. In fact, you can even see the Orion Nebula to the left. Rigel is this big star in the corner and the Witch's Head is to its right. You can really see that the nebula extends down a lot more than the previous image shows, but that's a discovery to be expected when you have improvements to technology. The final type of diffuse nebula, and probably my favourite one, is the absorption or dark nebula. So if the dust and gas that would form the nebula is very, very dense, and there isn't really a nearby star that's hot enough or close enough to heat it up substantially, then instead of like scattering or I guess emitting light, it can just block it completely. This is also kind of evidence from the fact that the spectra of these nebulae tend to show some really interesting molecules and compounds which usually don't form if the gas is very hot. So that's a fun chemistry fact for you. The Absorption Nebula that I think is probably the most famous one is the Horsehead Nebula. This is a very tiny section of absorption within the massive nebula that is the Orion Nebula. In fact, I think you would probably struggle to pick it out in most images of the Orion Nebula, and that's probably mainly because its strength can vary depending on the wavelength that you observe it in. We all know that infrared or near infrared can penetrate dust a little bit better, so it tends to look a little bit more translucent in those wavelengths compared to, say, optical. Now, that being said, my favourite dark nebula of all time is Barnard 68. This is in the constellation of Fucus, which is also my own zodiac, and yes, I use the 13 zodiac signs, not the 12. And the reason I like it so much is probably because, one, it is quite creepy looking in a way, and two, you can really see the reddening effects of dust on the outskirts of this nebula, because you can see on the edges the stars become dimmer and a lot redder. And this is kind of interesting because dust extinction is so annoying in observational astronomy, and it's really difficult to sort of quantify how much extinction you can get within the galaxy or within certain stellar systems or whatnot, depending on the amount of dust, because it's so difficult to observe. And yet here it's so clear and open and it's just staring right at you. It's so amazing. I want to give a very special shout out to one special diffuse nebula. That is the Trifid or Trifid Nebula, also known as Messier 20. It's lit up by the O-type star HD 164492A, and yes, I do know that's correct. I have memorized it. It's quite a unique nebula because it kind of has features of all three different subtypes wrapped into one nebula, which is very unusual and very cool. Furthermore, this image was taken only a month ago by the Vera Rubin Observatory, bringing us the best image we've got of the nebula so far. Vera Rubin's pink area is the actual emission parts of the nebula. It's also covered by these filaments of dense dust which block out sections of light. So we've got a bit of the Absorption Nebula aspect going on as well. And this is all surrounded by a very interesting ring of blue, which is where the star's influence is much weaker, so the light is mostly just being scattered and thus reflected. Now that we've covered the diffuse nebula, let's talk about some other special cases and more rarer types of nebula. Planetary nebula are technically a subtype of Emission Nebula from a mechanistic standpoint because there is some gas ionization going on, but they're not actually all that diffuse in some cases, so they're kind of just considered their own thing sometimes. These are usually quite small compared to diffuse nebula and are created when a solar type star comes to the end of its life as a red giant. When the star is reaching its final collapse into either a white dwarf or sometimes it can just be a stellar nucleus, the outer layers are ejected and are ionized by the remaining core of the star. This image of the Helix Nebula is probably my second favourite image of a planetary nebula. You can barely see the tiny star that's powering this nebula, but the colour gradient and the little stripes are very striking and quite mesmerising in my opinion. That being said, my favourite planetary nebula of all time has to be the Ring Nebula. This reminds me of some of those tumble gemstones you can find in gift shops, and the rainbow gradient is just so beautiful, and the inner blue section, it's so dreamy and mystical and just very whimsical. I love it so much. In fact, it reminds me of this chrysoprase pendant that I made myself from a gemstone that I found locally. I don't know if the camera's going to pick this up, but I might have to take an image of it, take a picture of it and post it. But you can kind of see how it sort of looks like a deep sea, I would say landscape, but I guess it's called a seascape. But it kind of reminds me of this nebula, and I guess the nebula also reminds me of this pendant, and it's really amazing just to look at. I can look at it for hours. Finally, the more massive counterpart to planetary nebula are what's called supernova remnants. And these are kind of made in a similar way to the planetary nebula, but with a much more massive star that has collapsed and created a supernova that is the explosion or the bright light that we see in the sky, and it leaves behind usually a neutron star as opposed to a white dwarf, but also as it ejects its shell, that shell is instead called a supernova remnant. Now I know we all love the Crab Nebula, or Messier 1, to be more formal, but I think my favourite supernova remnant is the Veil Nebula. This is actually one of the biggest nebula in the night sky. It stretches across the sky by about 3 degrees, which is massive, and it has such an intense, rich blue and Bordeaux colour. It reminds me of kind of like shot velvet, which is basically two-tone fabric. It's so beautiful, honestly. I love this remnant so much. That's all for today. I hope you learned something new, and I hope you were really, really mesmerised by these nebula as I was when I was researching for this video. If you like this kind of content, I highly recommend you subscribe and stick around, and I'll see you in the next video where we talk about galaxy classification. Bye for now.